Alright, hello algebra students. Today is 3.5, domain and range. This is day 2 of our discussion of domain and range. So get out your notebook, write down the title and today's date. Alright, this stuff is in your notes, but we'll review them. A function, remember, is a dependency relationship where the input values, which are the x values, do not repeat. To determine if a relation is a function, you compare the x values to see if they repeat, or you can also do a vertical line test. Remember the words for domain: input values, independent variable, the x values, and the words for range: output, dependent variable, and y values. So here you do not have to write these down, but I do want to show you examples of what you're going to be doing. I'm going to give you a graph and ask you to find the domain and range. Domain would be listing your x values, range is listing your y values. So here is a graph of these points. Example 2 is a function, and it asks me to list the domain. For this one, the domain is all real numbers, which is this capital R, and the range is going to be y is greater than or equal to 2, because all the y values start at 2 and go up. And the x values go on and on forever in each direction. So you don't have to write those are just examples. There's another one here, so you can just kind of see what we're going to get into. So here I have a function here, a graph, and I'm asking you to find the domain of this graph. That means all of the x values. So you're basically looking at a point here. So this green line is telling you what the domain is, because the domain goes from this point at -3, but it has an open circle. Open circles means that that value is not included. And then it goes all the way over to a +3. So this is the way you would write it. X is greater than -3 and less than 3. And then this is an example of range. So range starts here. Remember, range is this value, your y's. So it starts here at -2 and goes all the way up to +4. So the range would look like this. So we need to teach you how to do this. So let's get started with some terminology. Okay, so first of all, whenever a line, you see this open circle, a line is graphed and it has an open circle, that means the value is not included, and usually you use a parentheses on that particular side of the list of the domain. I'll show you what that means. And then if you see a closed circle, that means the value is included, and you would use a bracket instead of parentheses. So write that down, even though you may not know exactly what I'm talking about. Alright, remember the way you're going to list the domain is the way I'm going to ask you to do it is this way. You're going to put the least x value, and then a comma, and then the greatest x value, and then you'll use parentheses. That's not the only way to do it. And then the range would be the least y value and up to the greatest y value. And it would look like that. Let's discuss infinity, because infinity will be something that you will see with domain and range. And some graphs go on and on forever on a number line. So it'll have an arrow at the end. So when that happens, that means infinity could be the domain or the range. So when the least value is -infinity or the greatest value is infinity, you use less than and not less than or equal to, because infinity is not finite. It's not a quantity or a number. It's a property that is possessed by every quantity. So write that down in your notes. Again, even if you don't quite understand it, we'll explain it to you in class. Okay, so this would be example 1. So here we have a graph. So I want you to graph this on a sheet of paper, put example 1, and then one of the best ways to do this first is just to look at it and say, is this a function? Well, if we do the vertical line test and draw a line vertically anywhere on this graph, you know it's only going to cross one point. So since it only crosses one point, it passes the vertical line test, which means yes, it's a function. the domain, we're going to list the domain, and we're going to do that using parentheses or brackets, depending on, and you're going to put the least x value, and then you're going to put the greatest x value. So domain, remember, is your x's. So on this graph, if you look at this graph, what is the least x value that it could be? Now remember, this is the x-axis. So you want to put, what is the least x value? Well, at this point, if you look where the graph starts here, it's 0, 0. It starts at 0. So x is going to be 0. And so the least value of this graph, because it doesn't go to the left anymore, the least value is 0. All right, and 0 is included because this is a closed circle. So if it's included, then we use a bracket. So I know that that ends there and includes 0. So I'm going to use a bracket when the value is included and there's a closed circle. Next, we want to look at the fact that this line has an arrow at the end, which means it goes on and on forever to the right. So that means this will go on forever to the right, and x values go all the way to the right. So that means the domain goes from 0 to positive infinity. From 0 to positive infinity. Now we use okay, and then we're going to use, whenever we have infinity, we just use parentheses on the end. The other way you can write this is that you would put the x here in the middle, and then the least value, remember, is 0, so you'd put it on the left, and the greatest value is positive infinity, and then you would use greater than or equal signs. So 0 is less than or equal to x. That means x can be included, and you would use braces for this. And then x is less than infinity, but not including infinity. Anytime you use infinity, you don't use the line underneath. So both of these are correct ways to draw the domain. Now if we look at the range, so again, I'm gonna move this up a little bit so we can see it. So the range, remember, is your y values. So if we look at the range, we're gonna do parentheses, and then parentheses, and then a comma. And then we're gonna do the same thing over here. We're gonna do braces, and we're gonna put y in the middle, okay? All right, so we'll look at your y values. Your y value, remember, this is the lowest point of this graph is right here. So the lowest y value is 0. And again, it keeps going on and on forever, and it's going to keep going up as well. So the range is also going to be from 0, which is the lowest point with the bracket, all the way up to infinity with the parentheses, which means we're going to put 0 here. We're going to put the greatest value, which is infinity, and the same one, 0 is less than or equal to y, which is less than infinity. So that's going to be the domain and the range of that function. All right, let's try another one. All right, so draw this graph. This is example 2. All right, so look at this graph and draw it. And the first thing you want to do is look and see, is it a function? If the graph is a function, it has to pass the vertical line test, and it does. So yes, this is a function. Each x has only one y, and it passes the vertical line test. And then we're going to list the domain. First, what we're going to do is start at the starting point, which is a closed circle, and we're going to identify that point, and it's -2, -1. So -2, 1. Now we're going to think about the domain. So the domain is your x value. So I'm going to do this 2 ways. I do it in parentheses, and I'm also going to do this where I have to decide what is my lowest value of x. My lowest value of x goes here, and my highest value of x goes there. All right, so let's think about this graph. This graph is going, it starts here, and that's the point that is farthest to the right. That means that on the x-axis, it doesn't go to the right anymore. The farthest it goes to the right is -2. So negative 2 is actually the highest value of x. And the highest value of x goes here, and the highest value of x goes there. All right, so negative 2, does it include negative 2? Yes, it does, so that means I'm going to have a bracket where the negative 2 is. Now I have to find the least value of x. So what could x be? If I keep going this direction, x can go to what we call negative infinity. So negative infinity would be the least value of x, and I'd have to put that here as well. And that's a horrible sign. And then I have, but that's okay. Now I have to do, so this one is done over here. This is my domain from negative infinity all the way to negative 2 included. And here I would write it as x is greater than or equal to, not equal to, but greater than negative infinity and less than or equal to a negative 2. So this actually goes right here. That's the domain. The range we're going to look at again. So we're going to write it like this. That's the range with your least value and your greatest value. And then I can also write it with the brace and put the y in the middle. All right, so my least value, let's see, this is negative 2, 1, negative 1. My bad, that's a negative 1. So negative 1 is actually going to be your largest value of y because it keeps going down. So negative 1 would be your largest value. So we're going to put a negative 1 there and a negative 1 there. And then the least value, again, is going to be negative infinity. So I would put the same symbols here that I did on the other one. So this is your range for this function. All right, here I have example 3. So write down example 3 and draw this graph on your paper. All right, notice about this graph, it has arrows on either end. But before we talk about that, we need to decide, is this a function? Yes, it is a function because it passes the vertical line test. So yes, it is a function. Now we need to do the domain and the range. So let's do the domain first. Remember, domain is your x values. Well, if you look at this particular graph, it has arrows on either side. So that means it's going to go on and on forever to the right, on and on forever to the left. So this one's pretty easy to do when it has that. You're just going to draw your parentheses, and you know that it's going to go on for infinity to the left and to infinity to the right. So this would be a list of the domain. You could also write this as x in the middle, and then you'd put negative infinity here, and then you'd put positive infinity there, and x is going to be greater than negative infinity but less than positive infinity. Another way to write this is that the domain is equal to what we call all real numbers, so that real weird looking r that you've seen before. So you'll see this a lot, and that's an easier way to write it because x goes on and on forever, so the domain could be any number that you could think of. All right, now we need to do the range. So the range are your y values. And the range is also going to be infinity because if you keep going, not only does it go to the left and the right, but it's also going up to the left and down to the right. So your range is going to be all real numbers as well. So range is all real numbers, domain is all real numbers, and this is another way to write both of those, except that you would put a y right there. Okay, let's see what else we have for you. All right, here we would have example 4. And example 4, we need to find, is this a function? Well, if we do the vertical line test on this one, we can see that if I draw a vertical line, then it's going to pass at all the points. So there's no way that this could be a function. It does not pass the vertical line test. So this is not a function, but we can still list the domain and the range. So the domain, what can x be? Remember, domain is your x values. So the domain for this particular equation is going to be the same. So no matter where you graph a point on this, x is going to be 2, because this is going to be 2, 1, then you have 2, 2, and then you're going to have 2, 3, and then you have 2, 4, 2, 5, 2, 6, and you have negatives. So the domain x is equal to 2. Now if you want to find the range, so the range is all of your y values. That means the values of y up and down this line. So what can the range be? Well, you have arrows on either end. So the range is going to be equal to all real numbers, because it goes on and on forever, up and down. That is a horrible looking R, but that's the range. All real numbers. Now we have example 5. We'll start out with the domain. The domain is your x values. So what can x be? You see you have arrows on either end. And so this line can go on and on forever for both ways. So that means your domain is equal to all real numbers, or x, you would say negative infinity to positive infinity. That's going to be your domain. Your range, well, range is your y values. So your y values are here. The only y value you have is negative 3. It's negative 3 there, negative 3 there, negative 3, negative 3 there, negative 3. So for the range, it's going to be negative 3. So y will be equal to negative 3. All right, and here we have example 6. So draw this particular graph. Is this a function? If we do the vertical line test, no matter where we draw the line, it will only cross at one point. So yes, this is a function. Then we look at the domain. The domain, again, that's your x values. So what could x possibly be on this line if it keeps going on and on forever to the left, on and on forever to the right? So your domain is equal to all real numbers. Again, all real numbers. And then we need to find out what the range is. The range is going to be your y values. And then we look at what is the lowest possible point on this graph. The lowest possible point is right there. So this is the lowest possible point. It is at 1, 2, 3, negative 4, 0. No, 0, negative 4. X and y. So negative 4 is the lowest value that we have, and we do see that it will go on and on forever going up. So we start at the lowest value, which is negative 4, and to the highest value, which is positive infinity. So does it include negative 4? Yes. So then we would put a bracket right there. So this is one way to list the range. The other way to list it is to use braces. Put the y here, braces there. The lowest value you would put on the left, that's negative 4, and then positive infinity on the right. So negative 4 is less than or equal to y, which is less than infinity. So that's how you would write the range. Okay, and now we have the last example. I believe this is example 7. So draw this graph on your paper. And we can see, first of all, I notice it has arrows on either end. But I want to decide, is it a function? So if it's a function, I can draw a vertical line anywhere on the graph, and it will only cross at one point. And yes, it is a function. So then we need to list the domain. Again, domain is your x values. And because the line has arrows on either end and it's going to continue and continue going, that means the domain has to be all real numbers and the range has to be all real numbers. So the domain is all real numbers, and the same thing, and the same thing with the range. And I believe that's it. So hopefully you've learned a little bit about domain and range in this particular video. I'm sure you'll have questions, and I'm sure we'll have to practice this, but at least you have some idea of what domain and range is for us to learn more. All right, thanks. Have a great day.